This problem from the chapter 3, normal distribution. Most graduate schools of business require applicants for admission to take the Graduate Management Admission Council's GMAT examination. Scores on the GMAT are roughly normally distributed with a mean of 525 and a variance of 125.44. Here variance is given. Then let me take x for the scores on the GMAT. I use x. Then x has normal distribution, mean is 527 and standard deviation. So variance is sigma to power 2, it is 125.44. Then how do we find the standard deviation? Square root of 125.44. It is 112. Therefore we use 112 here. Now go to the part A. What is the probability of an individual scoring above 500 on the GMAT? Right. Probability above 500. X is the scores above 500. This. Now you see here we have greater than. If you see greater than or greater than or equal, you should write first 1 minus probability x less than or equal 500. Then we can write 1 minus. Now you see here we have x. So we need to make it z. It means x convert to z. So we need to find the z score. How do we find the z score? Z equal x minus mu over sigma. So x here 500 minus mu 527 divided by sigma is 112. So this is negative 0.2411. Probability z less than or equal negative 0.2411. Right. Now we need the probability. Then how do we find the probability? Go to the z table. What do we need to find? Probability z less than or equal negative 0.2411. But for the z value, we have only 2 decimal places. So as an example, how do we find the probability z less than or equal 1.329? Round this number to the 2 decimal places, then 1.33, then go to the 1.3 here, then O3 is here, then the probability is this, right? The intersection, number at the intersection. So similarly, how do we find this one? So here we have 0.2411. So I can write probability z less than or equal negative 0.24. Negative 0.24, negative number here, 0.2 here, 0.2, then 4. 4 is, you see this column, therefore the probability is 0.4052. Therefore here probability 0.4052. Then we can get the 0.5948. So that is the probability x greater than 500. So this is continuous. Normal distribution is continuous, therefore x greater than 500 is the same probability x greater than or equal 500. Go to the part B. How high must an individual score on the GMAT in order to score in the highest 5%? So this is normal distribution. We know it is mean is 500. So that should be here 500. And sigma equal 112. Then asking top 5%, right? Highest 5%. That means we have 5% here. This is the 5%, that is 0.05. So we need to find this value. I say it is A. In notation, I can write probability x greater than or equal A equal 0.05. Now compare with the first one. First one, x less than or equal 500. That means we were looking for a probability because we knew the value in the parentheses. But here we know the probability, here 0.05, we know the probability, we are looking for the number in the parenthesis, which is A. Right, you see here again, we have x greater than or equal A. We cannot use the table keeping x greater than or equal. Therefore, we write this 1 minus probability x less than or equal A. So this is 0.05. Then we can simplify this, x less than equal A, which is 0.95. Right. Now, what is the next step? Because here we have x again, right? You see we have x. So we need to convert to the z, right? So how do we convert to the z? This one. We know probability z. So, okay, now we need to convert A to the z value, right? Then z value of A equal A minus mu is 500 divided by sigma 112. A minus 500 divided by 112. This equal 0.95. I will write this with 4 digits because this is the probability. The table gives the probability with 4 digits. Now, once you convert to this z value, you see this side is z value and this is the probability. We are looking for simple A. Then we go back to the table and find the location of this probability 0.9500. If you go to the Z table, you see 0.9500 is in between these two numbers. 0.9500, then here you see 0.9505 and this one 0.9495. So 0.9500 must be in between these two numbers, right? And also difference between these two numbers 0.0005 and this one also 0.0005. In this case, how do we find the z value? Yes, we find the z value of this number, right? Okay, let me go with that. This is the 0.9495. So z value is 1.64. So I write down here 1.64. Then go to the next z value for this one, and that is 0.165. Then 1.65. Then get the average. How do you find the average? 1.64 plus 1.65 divided by 2, that is 1.645. And this is the z value we use for this problem. Right. Now we know z value from the table. Z value for the 0.9500 is 1.645. This is from the z table. Once you find the z table, you can get rid of these parentheses and write the terms on the inside one. A minus 500 over 112. Then we can solve for A. A equal 1.645 times 112 plus 500. So this is 711.24. So that is the A value. That meaning probability of x greater than or equal 711.24 equal 0.05. Actually we were looking for A. A is the 711.24. There is a short way to do that, but you have to be careful when we use it. Because when you have something like this, probability x less than equal a, suppose this is, I take the same example here, 0.95, right? Then we can write this a equal z value for this, okay? Corresponding z value for this probability, z value for that probability, then multiply by sigma and plus 500. You can use this one, but you have to be careful with this. It is the z value of the probability. This also must be always less than or equal.